Hey guys, Mr. Dell here. I am looking at a few of the problems today that you've had for your homework while on our first week of distance learning. So, eighth grade math, looking at the packet, and specifically got to ask a couple questions around multiplying and dividing rational numbers, specifically numbers that have decimals within them. So I'm on that second page here, and I'm going to just do a couple questions, couple problems, looking at number 39 and then 43. So that's going to be this video. So let's start with 39, number 39. Number 39 is 17 and 6/10, and we're multiplying that times 4 and 3/10, right? When we're multiplying numbers that have decimals within the number, a tenth, a hundredths, thousandths, whatever it is, the key is the same as how you would multiply other multiple digit numbers. Line them up, and in this case, the decimals do line up, but it wouldn't matter if they did or did not, because at the end, it's all about how many decimal places were there in the beginning, right? So let me move that down here. So I line them up as normal, and this is doing it without a calculator, and that's what I need you to know how to do. So we're going to multiply as we normally would. The normal algorithm for multiplication is multiplying our first digit to each of the digits above, and so on and so forth. So we'll do this. 3 times 6 is 18. Carry the 1. 3 times 7, 21. Plus 1 is 22. Carry the 2, the tenths. 3 times 1 plus 2 makes that 5. And then again, we have our space here. We don't, some people use an X, some people just put a 0, but your space needs to move over when you go now to the tenths. I'm multiplying in the tenths place here. The tens are the ones here in this situation moved over once. 4 times 6 is 24. Carry the 2. Don't need that anymore. 4 times 7 is 28. Plus 2 makes it 30. So put down the 0. Don't need that. Carry the 3. 4 times 1 is 4. Plus 3 is 7. So we have our digits lined up. Our space here. So that is 8 plus that 0. 8. Add those up. We get 6, 5, 7. So I have this number that is a 4-digit number, but then I go back and I look at my original 2 numbers that were being multiplied, and I find out how many digits were behind decimal places, right? So there was 1 digit, 2 digits behind decimal. So there's 2 digits behind a decimal. So I'm going to have in my answer 2 digits behind the decimal. So this is my answer here of 75 and 68 hundredths. Okay, final answer. Oh, that one. There we go. Oop, 75 and 68 hundredths. So as well, let's do one with division. So number 43 I'll do as an example. So number 43 is negative 6 and 15 hundredths divided by negative 8 and 2/10. So right away, the first thing I'm going to look at is the signs. I know I'm dividing 2 negative numbers, so my answer will be positive, right? If they were opposite signs, it'd be a negative, because a positive divided by or times a negative is always a negative, and vice versa. Negative times a positive is always a negative. But if I multiply or divide 2 negatives, I get a positive, right? So in this case, when we do the division, and we're needing to do it by hand, not with a calculator, so I'm dividing 6.15 or 6 and 15 hundredths, dividing that by 8.2 or 8 and 2/10. And when you're dividing with decimals, the whole key here, the idea is what we want to do is we take and we don't want to divide by anything that has a decimal equivalent. So I'm going to move my decimal place once over to get it to be a whole number. So really what I'm wanting that to be now is 82. And that's the same thing then what I would do as well is move this one over one space. So now I'm dividing 82 into 61 and 5/10, right? And then the decimal, we know our answer. The decimal place lines up when we're looking at long division, the long division algorithm. And at that, now we're looking to see, okay, how many times does 82 go into, we ask how many times does 82 go into this 61? And it does not go in evenly. It doesn't go in even once. So I'm going to put a 0 there because I know I have my place of my decimal place there. So then I ask how many times is 82 going to go into 615 when I look at that whole number as a 3-digit number. In this case, I think it looks like 7 times. So I'm going to multiply by 7. And how I did that is I looked at 7 times 8 or 7 times 80 is 560. So I knew that was close. And if I put an 8 here, 8 times 80 would have been 640, which would have been too much. So if I multiply the 7 times the 82, I get 4, 157. So I end up with 574. And I'm going to subtract that, right? The long division algorithm. 1. And when I subtract those numbers, 61 minus 57 is 4. So now I have 41. And if I look to see, okay, does 82 go into 41? Of course it doesn't. So not evenly. So I'm going to bring down a placeholder of 0, right? So bring down that 0. Now I ask how many times does 82 go into 410? And I believe it's 5 times. So multiply by 5. Sure enough, it is 5 times. And I subtract, and now I'm good. So my final answer here is that, there we go, is that 82. So actually, we'll look at it up here. Negative 6 15/100 divided by negative 8 2/10, right, is equal to 75 hundredths, okay, 0.75. And that's my answer for this one. So dividing, multiplying numbers with decimals, little reminder and a review. All right.